amazing people, students, lovers of chemistry out there. I'm excited to be here with you on today's episode of Question for the Day. And today we want to look at an ideal gas law, which is calculation based. Okay, the question on the screen says a sample of gas occupies 0.6 decimeter cube at a temperature of 27 degrees Celsius and a pressure of 100 kilopascals. Calculate the number of moles of the gas. Now, this is the ideal gas law, and the ideal gas law has an ideal gas equation that says PV is equal to nRT. Now, each of these variables have what they represent, okay? P stands for pressure, and then V stands for volume, N stands for number of moles, R stands for the ideal gas constant, and then finally T stands for temperature. Now, before we go into imputing our variables into the equation, there is something important that I want to show to you that you need to know. Now, the value of the ideal constant is very important, and it can vary depending on the units that are used in the gas law. For instance, now, when R is 0.0821, pressure has to be measured in atmospheres, volume has to be measured in liters or dm cube, and temperature has to be measured in Kelvin. Now, in our own case, R was given to us as 8.31, which is this value here. And pressure has to be measured in pascals, volume has to be measured in cubic meters or meter cube, and temperature has to be measured in Kelvin. That tells us that we have a lot of converting to do before we even talk about solving this question. So for the first value, which is volume was given to us as 0.6 decimeter cube. We need to convert this to meter cube or cubic meters. To do that, we simply say 0.6 divided by 1000. So when we do that, we have 0.6 divided by 1000. That gives us 0.0006 meter cube. So now that we have converted our volume, we need temperature to be in Kelvin. Temperature was given to us as 27 degrees Celsius. To convert it to Kelvin, we simply add 273. Doing that, we end up with 300 Kelvin. Now we've converted temperature into Kelvin. The next thing is pressure. Pressure has to be measured in pascals, but we were given 100 kilopascals. To convert from kilopascals to pascals, we simply multiply by 1000. So that gives us 100,000 pascals. So now that we have all these values set and ready, let's impute it into our formula. PV is equal to nRT. Pressure here is 100,000 times volume, which is 0.0006. This is equal to N is unknown times R, which is 8.31, times T, temperature is 300 Kelvin. So doing that now, we have 100,000 multiplied by 0.0006. That gives us 60. So 60 is now equal to 300 multiplied by 8.31. That gives us 2,493 N. So to find N, we simply divide both sides by its coefficient, which is 2,493. So this cancels this, and then N is finally equal to 60 divided by 2,493. That gives us 0 0.0241 moles. So we've calculated the number of moles of the gas to be 0.0241. I'm sure you saw how that was carried out. If you enjoyed every bit of this conversion, of the conversions we carried out, and how every step was taken to solve this, please like this video, share, and subscribe. And I'll see you on the next episode of Question for the Day.